Today is what, April 22nd, and well, you guys just took a quiz. I just input the last quiz grades from last Monday, and they were not very good. So I'm doing a review video. Again, I told you guys prepare Sunday night, and it looks like a lot of you did not. I'm sorry. Well, I tell you that every Sunday, prepare every Sunday night, and you guys just don't appear to be doing it. So really struggling here to keep doing these review videos when I feel like you're just not putting the effort in initially. And it's just creating more work for me. So anyway, that's where I'm now on the review. So I'm just going to go over these problems. I told you this is your quiz. Like I said, and again, there was more stuff on it, but that was one of the theorems we learned. That was one of the theorems we learned. That was one of the theorems we learned. They are all on page 239, I believe it was. Those are. On page 239, I said, know those three theorems. We did practice problems with those three theorems, and I gave you formulas. And don't believe the book has the formulas. So if you didn't get the notes, you need to go back and watch the videos. I mean, I guess you'll see them here. We're going to use them in a second and do a couple of problems. But again, I don't know how you expect to do well in this class if you don't prepare the night before. It's just not that kind of class where you can do a little tiny bit of work in class and then retain it all the way through the quiz. That's just not going to happen. So you got to start putting the work in. We got a few more weeks left, some extra tickets. You want to get your grades up if you have to be accountable for your grades. Get rid of that. All right. So first problem was old material, but just to review, anytime we have an angle that is a central angle means the vertex is in the center of the circle. We said the arc matches the angle. So if the arc is 65 degrees, then that angle is 65 degrees. And we can kind of see that if we keep opening the angle up, so that's about a 90-degree angle, well, the arc would be about 90 degrees. I mean, they'd be the same number, whatever it was. Like, I'm just guessing that it's 90 degrees just by looking at it. If I made it a diameter and went all the way across, well, we know the angle, a straight line, is a measure of 180 degrees. Well, the arc would be a semicircle, so it would be 180 degrees. So again, central angle just matches up with the arc. Then we did inscribed angles later. We proved it. I'm not going to worry about proving it here. We said the measure of the angle is 1/2 the arc. So x would be 42 divided by x. If we were going from the angle to the arc to figure out the arc instead, we would multiply by 2. So again, if we solve that out, we would get x is 21. Well, we could go the other direction. 21 times 2. So again, 21 would represent the angle. 21 times 2 would get us back to the 42 that is the arc. All right, so here's the first one that was on the quiz that I just graded and input. Quiz you took on, what was yours? 15. We said anytime you see two lines crossing inside a circle, and they could continue to go. They didn't have to like be chords. They could be what we called secants, and they could go all the way through the circle. Basically, the lines cross inside the circle. Anytime we're talking about angles and arcs, we learn the formula. So the first question is you have to identify that we're talking about angles and arcs. Well, that's pretty easy because all of those get measured with degree symbols. Angles are measured in degrees, arcs are measured in degrees. If there's no degree symbol, then it's not about angles and arcs. It's about the length of line segments, just like everything else that we've learned. So this is definitely about angles and arcs. So we said there was a formula. I'm not going to write it super large because you're watching a video and you can. Arc 1 plus arc 2 divided by 2 equals the measure of the angle. In either angle. It could either be this angle here, or it could be that angle there, because we said those are vertical angles. They have the same measure. So it doesn't matter which arc we are trying to solve for. They both have the same number. So the measure of one of those angles is equal to arc1 plus arc2 divided by 2. Now the formula, that formula never changes. So you might plug in information into different spots. Like in one problem, they might give us both arcs. And we would plug in both arcs and we would be solving for the angle. In another problem, they might give one of the arcs, not the other arc, and then we solve, and then they give us the angle, so we're actually solving for one of the arcs. In an even different problem, we may have to try to solve for what the arcs are. We may not have any information about the arcs right where they're at, but they may tell us like the other arcs that we don't know, that we're not solving for. They may tell us those measures. So like, I'm going to get rid of all of that. You can rewind if you need to. So instead of giving us that 31, actually, they might have to give us that. They would give us that arc, and they would give us that arc. And we may have to solve for one of the arcs that we need. So that could also happen. Just realize, though, it's the two arcs. When it comes to which arcs, it's always these two arcs. You have to have those two arcs because they are the arcs that are like corresponding to the angles. They intercept, or the angle intercepts those arcs. So those are the two you have to use. You just may have to do some math to figure those out first, because they may give you something else, like they may give you these sections here. And something else, there'd have to be another way to figure out like what those arcs were. Anything. Just, that's why I always say, just do what you know. Fill in whatever information you can fill in first before you even worry about what the question is. Then once you've done that, come back and read the question. And now the problem may not seem quite so intimidating. This last one's not, I'm going to go over this next class. I'm not going to spend any time on it, but that one was not on the quiz. That was on the quiz before. So if you're doing a retake, you will get a review on that in class Tuesday or Wednesday, depending on your class period. All right, so this was on the quiz. That was on the quiz we just took. So again, we said this is kind of similar to an inscribed angle. We have a vertex, so that's kind of the corner of the angle, that is on the circle. So kind of similar. There's my angle. Well, it tells me that angle is 75 degrees. Well, we learned a formula that just said, just like, God, my board is I'm going to have to probably fix that. I'm crazy. We learned a formula that was the same formula as up here, where we did the inscribed angle. It said that the arc, so this would be the arc inside the angle. You could think of it as kind of like it's the arc inside the angle up there. It's the arc inside the angle that is twice the angle. So that red arc is just the angle, which we know is 75 degrees times 2. So that arc is 150 degrees. Now, here's the tricky part. They might not ask you for that. One of the problems in the book, and I didn't even catch it initially, actually didn't ask you for that arc. It asked you for that arc. So the math is still the same. This one is still 150, but then you were supposed to subtract that from 360, because we know a whole circle is 360. So if we know this red arc is 150, then the green arc would have to be 360 subtract 150, whatever's left. So just be careful of what you need to solve for. So that was, the formula was 1/2 the arc equals the angle. So if this is the that's the arc, we would take 1/2 of that to get the angle, which we already knew was 75 degrees. So the opposite is true. Twice the angle. Redo that. Oh, God dang it. Hold on. Just did this right before the video. All right, let's try that again. Oh, it's still not working. So again, if I have the angle, like this problem, the arc is 2 times the angle measure. So that arc is 75 times 2, which we got 150 a second. Now, if for some reason we didn't have that, so let's say we didn't know this part up here, and they asked us to solve for the angle, well, then they would have to give us some information so we could figure the arc out. Now, if we want to solve for the angle, we would say 150 divided by 2. Again, the arc is twice the angle is half of the arc. So then again, we get the 7. All right, so here's the last situation. So again, we said when 2 lines cross in the circle, that's when the vertex, or you could kind of say the lines are crossing on the circle. So where they would cross if they kept going is on the circle. And finally, this one is where they cross. So where they cross is outside the circle. So 3 different situations. And this one has a different formula. We said this formula was the big arc. Subtract the little, I don't know why I always do little arc. And then all of that would be, oh boy, try to write slowly. I didn't fix it. Divided by 2. And again, that this may not write very well. And that would equal the angle. And when we say the angle, we're talking about right in that angle right there. So when it just comes to the arcs, again, it's the arcs that are inside the angle that we're talking about. So that arc there, that arc there. So the bigger arc is just the one that visually is bigger, or in this case, they gave us both of them, so we just use the numbers. So the measure of angle E is the big arc, subtract the little arc, divided by 2. If you do the math on that, it's out to 11 newtons. So the quiz oh no, I'm sorry. Oh man, am I doing the wrong? I am doing the wrong video. Shoot. All right, so this is going to wind up being a 2 quiz review video. This is for the quiz you just took today. So I'm going to stop reviewing that and go to the other quiz now. Actually, I'm not going to do that. I'm just going to go ahead and continue to do this one, and then I'll do a separate one. This was on the quiz you just took. Again, I have not graded this quiz. It's the one you just took. We said if you have these 2 words, oh, God, I'm crazy. Let's try it again. So if you have the word circumscribed or inscribed, they really just mean, or the important part is the same for both of them. They mean different things, but what they're telling you really is just that you have tangent lines. All of these points are tangent points. The circle is inscribed in the quadrilateral. The quadrilateral is circumscribed around it. But what matters is it's a bunch of tangent lines. So, try to fix it one more time. So what we really just have is a tangent line here and a tangent line here. Tangent line here, and then a tangent line here. So instead of thinking of it as this shape around a shape, it's just a bunch of points outside the circle and then a bunch of tangents. So all those lines are tangent. And what's important was when that happens, when we have tangent lines coming from the same point, so that's a point there, that's a point there, that's a point there. So again, the two green lines are tangent lines coming out of the same point that is outside the circle. So this was a theorem we did a while ago, and it was on a different quiz. Now we're using it again, and just we're making it a shape instead of just two lines. But what's important, we said, is just that all of the lines that are the same color are congruent. Two tangent lines to a circle coming from the same point are congruent. So we said, well, that just means that then that's a 6, that's a 3, that's a 4, and that's a 1. Two blue lines are congruent, two yellows. So now you just had to understand what perimeter means, and that just means that we're figuring out how long all the sides are totaled up. So this side here, if we add those two segments, is 9. This side here, if we add those two, is 7. This side, if we add those two, is 5. And that one would also be 7. So that's one of the sides, that's one of the sides, that's one of the sides, that's one of the sides. And if I add all those up, I get 28. So that was the perimeter, length of all the sides added. I don't remember off the top of my head exactly what else was on today. There was one problem that was a little trickier that I'm just going to kind of go over some concepts on. I guess I can kind of use that right there. So if you have a circle, I'm going to just draw this in. It won't be perfect. And let's say you have a bunch of lines, and then you have some information about arcs. How did it go? I don't remember where the information was, so I'm just going to kind of do it without numbers. The point of the problem is don't freak out when you've got a whole bunch of stuff going on. I believe it gives you like one angle right here or something, and then I think maybe it gives you an angle down there, and there are two different measures. So all that you need to think about is, okay, well, what can I prove? Like start with the basic stuff we know. There's no central angle, so there's nothing we can do for central angles. So go to the next concept. Well, inscribed angles was the next concept. We got a bunch of inscribed angles, and it gives you the numbers for the angles. So let's say they're super small. Let's say this one down here is 8 degrees and this one is 10 degrees or something like that. But let's just do what we know. And again, hopefully you know this next piece. I know if I have an inscribed angle, the measure of that angle is half the arc. Or I know the arc is twice the angle. So I could say, all right, well, then I know this angle up here is, this arc is 16 degrees, just twice that. Well, I could kind of do the same thing and say, okay, well, if I know this angle is 10 up here, 10, well, then I could come all the way down. So I'm going to trace down to the arc. If you remember, we did this in class. You just trace the angle all the way down to its arc. So that arc is 20 degrees. Well, I also know some other stuff because I have two other, I'll start using a different color so you can see. This is also an inscribed angle, and this is an inscribed angle. Well, if you'll notice, I now know the arc associated with this angle. So I'm just going to trace the angle up. The arc associated with that angle is 16 degrees. Well, if I just know that one rule about arcs and angles, I know that this angle here is half the arc. Well, if I know the arc is 16, that one must also be 8 degrees. Kind of the same thing here. So again, I'm going to trace it in a different color. I know this is actually, I already know that arc. What arc? So I don't know this arc. So here's an angle. I'm sorry, I don't know this angle. So there's an angle here coming out of point B. And if you'll notice, that angle intercepts this arc right here that we know. So going back to that same theorem, I know that the angle is half the arc. So 20 divided by 2, that angle right there is just 20 divided by 2, half the arc. That angle is 10 degrees. Well, if you notice, we have congruent angles there, congruent angles there. I can solve for the measures of the missing angle if I need to, because if you'll notice, we have, how can I do this? It's kind of tough to do it on the black screen. I should not have chosen that. We have two triangles. Here, we'll do it in, we'll just change to, actually, we'll do it dashed. Definitely staying up. Here's a triangle here. One side, two sides, three sides. Well, if I know the two of the three interior angles of a triangle, I can solve for the third. Well, I do know two of the three. I know this one right here is 10. So that one is 10. I know this one right here is 8. So I could solve for that angle right there, that big angle right there. Again, you take away 8 plus 10 from 180, and that would be the measure of the big angle. 162. So that big angle would be 162. And again, if that's 162, because those are vertical angles, that one also would have to be 162. Or you could solve from taking away from 180, add these two together, subtract from 180, you'll get the same thing. And then finally, if I understand what those angles are, if I know that angle and the other angle is 162, I could actually solve for this angle here. I'm going to change to a different color. I could solve for this angle here because those are linear pairs. Remember how we said if we have two angles next to each other, they have to add up to 180. So I could solve for that. So again, I would just be saying 180 subtract 162. So that's the 162. And that would give me that the other angle here, this angle here is 18. Well, that would mean this one down here would be 18 because it's across from it. So they're vertical angles. So there was a whole bunch of stuff you could have solved for in that problem. Oh, and then there were a couple of problems that just dealt straight with formulas. You need to know, I'm not going to do these out. You need to memorize the formulas. It's just doing algebra, really, once you memorize formulas. Oh, yeah, here we go. So again, it dealt with lengths of segments, the other two problems. So if you see a problem like this, there was a formula in the book. I kind of did it a little differently and color coded it, but the formula was that the blue times the green, so the two small segments of one chord, equals the red times the yellow. So blue times green equals red times yellow. Hopefully you're not colorblind, but it's basically the two segments of one chord equal multiplied together equal to two segments of the other chord. That's when they cross inside the circle. When they cross outside the circle, we said the blue times the green. So again, we always use the lengths of one line, one segment, one secant, one chord, whatever they are. So the blue, which is the whole segment this time, up here we use parts, a part times a part. Down here, we're using the whole times the part, blue times green. So that would equal the red times the yellow. So again, we did a problem if you want to go back and watch the other video. Actually, I don't remember if we even got to those in class. But, it's not, I mean, it's not super complex. There are some problems in there that you can look at. The book helps you work out the example. I'm pretty sure we did it. And then the last one, let me get rid of it. Oh, actually, so you can't see the line underneath, but the blue line is a tangent. So there was a tangent line and it's intercepted or intersecting or whatever you want to call it with either a chord or a secant, doesn't matter which. And we would take both the pieces of the secant, the line that goes through, so that would be the secant or the chord, could be either secant or a chord. we take the entire length, which is the red, times the green. So that's what the red and the green are there for. So the entire length times the part that is outside. That's the green is the part outside, the red is the entire. So you see down here. So this would be the red, this would be the green. And then we set that equal to the tangent, which is the blue line, the tangent length squared. Remember, all of these are length. There's no information, there's no degree symbol anywhere in all of these problems on the right. So that would be your hint that you should be using these formulas. You don't see any degree signs. All right, and then I expect you to be able to do the algebra. You just need to memorize the correct formula for the correct situation. Here's a situation where the lines intersect on the circle. Here they intersect outside the circle. Here they intersect inside the circle. Formula is up above for the one inside. I'm not going to write all the other ones out. They're in the book if you need to look in the book. Or again, you can always come to me to get help. Go to tutoring if you can't come to me. I'll be tutoring though again Thursday, 2 to 3. And then G2 is always available. After school, well, I shouldn't say always. After school, 2 to 3, Monday through Thursday, and then either lunch is what I meant when I said always. Doesn't matter which lunch you have.